Hello and welcome back. Today, we are diving into one of the most transformative materials out there, rubber. It's that elastic wonder that gave us the grip, the seal, and the shock absorption that literally put the entire mobility revolution on wheels. But here's the big question. Is rubber a true S-tier legend, up there with titans like steel or concrete? Or is it more of a really, really useful, stretchy supporting player? Well, today, we're opening up the case file on rubber to figure out exactly where it lands in the great ranking of materials. Okay, let's get right into it. To even start this investigation, we've got to understand what rubber actually is. So first things first, rubber isn't just one thing. It really exists in two main forms, two sides of the same coin, if you will. On one side, you've got natural rubber. This stuff is a polymer called polyisoprene, and we get it by tapping this milky latex from the Hevea tree. But on the other side, you have synthetic rubber, and that's a whole family of man-made polymers, usually cooked up in a chemical plant from petroleum. And you know what? Both of them are absolutely critical to our modern world. Now, there is one single process that took rubber from being this sticky, kind of useless novelty into an absolute industrial powerhouse. And that process is vulcanization. See, before this discovery, the long polymer chains in rubber were like a bowl of spaghetti. They just slide right past each other. It made the rubber gooey when it got hot and brittle when it got cold. But by cooking rubber with sulfur, you create these little chemical bridges or crosslinks that tie all those spaghetti strands together. That's the secret sauce. Now, when you stretch it, the chains uncoil, but those crosslinks pull them right back into place, giving it that incredible strength, durability, and that famous elastic snap.
So, how did we figure all this out? Well, it's time to present the first piece of evidence in our case, rubber's pretty incredible journey through time.
Rubber's been with us for literally thousands of years. Ancient Mesoamerican cultures were using it for things like bouncing balls. But its modern story, that really kicks off in 1839 with Charles Goodyear's discovery of vulcanization. That one breakthrough set the stage for the 1880s, when the demand for bicycle and car tires just exploded. Then the story takes another huge turn in the 1940s. World War II cuts off natural rubber supplies, and that forced this massive government-led push to basically invent the modern synthetic rubber industry from scratch. And here's a little piece of trivia for you. The reason we even call it rubber, it's because one of its earliest uses in Europe was as a simple eraser, to rub out pencil marks. Pretty wild to think it went from that to a global industry, right? All right, so let's get into those unique properties. This is the next part of our evidence, the incredible physical abilities that make this material so darn valuable. Let's talk about its stretchy superpowers. Let's just pause on this for a second. 500 to 1,000%. That is rubber's signature move. It can stretch to between 5 and 10 times its original length and snap right back. Think about that. Very, very few materials on this planet can even come close to doing something like that. But hey, it's not just about the stretch. Rubber is incredibly resilient, which makes it perfect for damping out vibrations in engines or your car's suspension. It's naturally waterproof, that's why we use it for seals and hoses everywhere. It can be made super resistant to abrasion, and on top of all that, it's remarkably easy to work with. You can mold it, mix it with other stuff, and shape it into almost anything you can imagine. So okay, we've got a revolutionary material with some truly amazing properties. Now let's look at the evidence for its impact today, which, let's be honest, is completely dominated by one single application. And this chart just says it all, doesn't it? A staggering 70% of all rubber produced, and we're talking over 30 million tons a year, goes into making one thing: tires. Cars, trucks, airplanes, if it has wheels, it's riding on rubber. It's what gives us the grip, the comfort, and the safety that makes all of modern transportation even possible. And yeah, while tires are definitely the main event, that other 30% just shows how ridiculously versatile this stuff is. It's in all the other parts of your car, like the seals, belts, and hoses. It's all over industry as conveyor belts and gaskets, and it's in our daily lives, from the soles of our shoes to life-saving medical gloves. It's just everywhere. Okay, the case for rubber seems incredibly strong right now, but every material has its weaknesses, and it's time for the counterargument. Let's take a closer look at the cracks in rubber's otherwise perfect surface. Yeah, rubber's greatest strengths are kind of mirrored by some pretty big weaknesses. That natural versus synthetic split, it creates two different supply chain risks. Natural rubber is vulnerable to climate and disease, while synthetic is tied directly to the crazy volatile price of oil. And what's more, its incredible durability has a really dark side. Tire wear is a huge source of microplastic pollution. And that vulcanization process we talked about, well, it makes rubber extremely difficult and energy intensive to recycle. So it's pretty clear. Rubber is absolutely the bouncy enabler of modern life, but it comes with some very real stretch marks. We're talking significant environmental and supply chain challenges that we just can't ignore. All right, we've heard the arguments for, we've heard the arguments against. All the evidence has been presented. It is time to weigh it all up and deliver the final verdict on rubber. And as always, we're going to be judging it based on our 6 core criteria: its historical impact, its raw mechanical properties, how easy it is to work with, its scalability, its versatility across different uses, and of course, its relevance today. Okay, let's do this. For historical impact, it gets a massive 9 out of 10 for basically enabling the age of the automobile. Mechanical properties, a solid 9 for that unmatched elasticity and resilience. Workability gets another 9, it's just so easy to mold and shape. For scalability, it gets an 8. I mean, production is huge, but it's held back by those supply chain issues. Versatility gets a near-perfect 9.5 because, well, it's everywhere. And finally, lasting relevance gets an 8.5. It's still the king, but those sustainability pressures are a growing threat. And so, after all of that, we arrive at the final verdict. With an average score of about 8.8, rubber lands squarely in the high A tier. Look, its incredible combination of elasticity, durability, and versatility absolutely keeps it in the elite class. But those supply vulnerabilities and its pretty significant environmental downsides, they just prevent it from reaching that legendary S-tier status. You know, maybe this is the best way to think about it. If asphalt paved the roads for us and concrete built our cities, it was rubber that gave us the crucial grip and comfort to actually travel between them. It's the essential connection. And that leaves us with one final thought. Rubber is one of those things we barely even notice, yet our entire world depends on it. So my question to you is, what other invisible material do you think is absolutely essential to the way you live your life? Let us know what you think. Thanks for watching.